Black hole singularities are supposed to be the ultimate dead end, a place where density becomes infinite space-time breaks, and the equations of general relativity stop making sense. For 60 years, physics treated that as a verdict. In 1965, Roger Penrose showed that under reasonable conditions, gravitational collapse leads to geodesic incompleteness. The map runs out. The future ends. But in December 2023, Roy Kerr returned with a blunt objection. The end may be a measurement artifact, not a physical wall. We may have mistaken the limit of a parameter for the limit of reality. If Kerr is right, crossing the event horizon isn't a clean death. It's stepping into a region where prediction fails, and the universe itself no longer knows what happens next. So what if the singularity was never the end at all? For decades, physics answered that question with absolute certainty. It is the most terrifying location in the cosmos. A theoretical point where the density of matter becomes infinite, where gravity becomes absolute, and where the laws of physics cease to give meaningful answers. We call it the singularity. For generations, this point has haunted the dreams of physicists. It represents a fatal error in the operating system of the universe. When Isaac Newton first described gravity, it made sense of the falling apple and the orbiting moon. But when Einstein refined that vision, his equations whispered a darker possibility that gravity could become so intense it would create a prison from which nothing, not even light, could escape. But the true horror wasn't the darkness of the black hole. It was what lay at its center. In 1965, the British mathematical physicist Roger Penrose delivered what was considered the final verdict. In a landmark paper that would eventually earn him a Nobel Prize, Penrose proved that under the strict laws of general relativity, the formation of a singularity is unavoidable. He argued that once a star collapses past a certain point, space-time itself is forced to terminate. Think of it like a submarine diving into an abyss. Penrose calculated that no matter how you steer the ship, all paths lead inevitably to the bottom. And at that bottom, the pressure of reality becomes infinite. The story ends. For 60 years, this has been the old law of cosmology. We accepted that the center of a black hole is a cosmic dead end. But suppose the judge who signed that death warrant was looking at a flawed map. Enter Roy Kerr. He is not a rogue outsider. He is a titan of the field, the New Zealand mathematician who in 1963 discovered the exact solution for rotating black holes, which we now know make up 99% of the black holes in the universe. If Penrose defined the prison, Kerr is the engineer who described its true structure. And in December 2023, Roy Kerr returned from retirement to dismantle the very idea of the singularity. In a paper that sent shockwaves through the theoretical physics community, Kerr argued that we have fundamentally misinterpreted the mathematics for half a century. He suggests that the inevitability of the singularity is based on a subtle trick of coordinates, a confusion between the map and the territory. He claims that the infinite pressure Penrose predicted isn't a physical wall where reality stops, but merely a mathematical horizon where our standard measurements fail. Kerr is effectively reopening the coldest case in science. He argues that the supposed point of infinite destruction at a black hole's center may be a mirage. And if that point isn't real, then the interior of a black hole isn't a tomb. It's an unresolved structure. It is something else entirely. But to understand why Kerr dares to challenge a Nobel Prize-winning idea, we must first step inside the prison that Penrose built and see exactly why, for 6 decades, we believed there was no way out. To understand the verdict, we must first reconstruct the physical conditions under which it was reached. For centuries, gravity was seen as a force of attraction, a tether binding planets to stars. But when a massive star dies, gravity transforms from a tether into a crusher. When the nuclear fuel that powers a star runs out, the outward pressure that holds the star up vanishes. Gravity instantly collapses the star inward. If the star is massive enough, this collapse doesn't stop at a dense ball of matter, like a neutron star. It keeps going. It shrinks the star past a critical threshold known as the Schwarzschild radius. Once the matter is compressed inside this boundary, the gravitational pull becomes so intense that the escape velocity exceeds the speed of light. This is the event horizon, the one-way membrane of the universe. But the critical structure emerges only after you cross the horizon. In 1965, Roger Penrose analyzed the geometry of this collapse and identified a terrifying structure, the trapped surface. Imagine triggering a flash of light inside the horizon. On Earth, light spreads outward in a sphere. Inside a trapped surface, the curvature of spacetime is so severe that even light rays pointed outward away from the center are dragged inward. Space itself is falling toward the center faster than light can climb out. It is like trying to swim up a waterfall that is flowing down faster than you can swim. No matter which direction you face, your future lies in only one direction down. This is where Penrose delivered his masterstroke. Before his theorem, many physicists hoped that this collapse might be messy, that imperfections in the star would cause the matter to miss the center and bounce back out, saving the universe from a breakdown. Penrose proved that hope was mathematically impossible. He introduced the concept of geodesic incompleteness. In general relativity, a geodesic is the path that a free-falling object or light ray follows through spacetime. It is the thread that weaves the fabric of reality. A complete geodesic should extend infinitely into the future or past. Penrose demonstrated that once a trapped surface forms, these threads are forcibly cut. Inside the hole, the roles of space and time swap. The radial distance to the center becomes a unidirectional timeline. The center is no longer a place in space, it is a moment in your future like next Tuesday. Just as you cannot stop time from moving forward, you cannot stop your fall toward the center. And when you reach that center, the geodesic stops. The path terminates. The mathematical definition of the universe ceases to exist. This termination point is the singularity. It is a location of infinite density and infinite curvature where the laws of physics break down. It is effectively a point where the classical description of reality fails. Penrose's logic was ironclad. If gravity is attractive and an event horizon forms, a singularity must exist. This has been the dogma for 60 years. All paths end in the dark. For decades, no one questioned this conclusion. But there is a flaw in this perfect prison. Penrose built his case on a simplified model, a static, non-moving collapse. But the universe is not static. Real stars spin. And when you add rotation to the equation, the dead-end map suddenly reveals a hidden passage. Penrose's dead-end map was perfect mathematically speaking, but it described a ghost, a static, motionless black hole known as the Schwarzschild metric. In the real universe, nothing stands still. Planets spin, stars spin, and galaxies spin. When a massive star collapses, that angular momentum doesn't just vanish. It gets conserved, it gets compressed, and as the star shrinks from millions of kilometers wide to a point smaller than a city, that spin accelerates to relativistic extremes. Enter the Kerr black hole. In 1963, Roy Kerr, a New Zealand mathematician working in Texas, found the solution that had eluded Einstein's followers for decades. He described the geometry of a rotating black hole. And in doing so, he revealed that the prison has moving walls. A rotating black hole doesn't just sit in space, it grabs the fabric of spacetime and drags it along with it. This is a phenomenon known as frame dragging. Imagine the black hole not as a hole, but as a mixer spinning in a bowl of thick honey. The honey near the mixer spacetime itself is forced to rotate. As you approach a Kerr black hole, you enter a region called the ergosphere. Here the twisting of space becomes so violent that standing still becomes a physical impossibility. Even with an arbitrarily powerful rocket engine, no observer could hover in place relative to the distant stars. Space itself flows past faster than light, dragging everything in the direction of the spin. You are no longer falling into a static pit. You are being swept up by a cosmic hurricane. But here is the twist. This same mechanism radically alters what inevitable means. In Penrose's static model, gravity was the undisputed dictator. It pulled everything to the center, crushing it into a zero-dimensional point. But in Kerr's rotating model, there is a rebellion. Rotation creates centrifugal force, the outward push you feel when a car turns a corner too fast. Inside a Kerr black hole, as matter spirals toward the center, This centrifugal force grows stronger, fighting against the inward pull of gravity. Deep inside the event horizon, there is a regime where competing geometric effects dominate in different directions. And because of this outward push, the singularity cannot collapse into a single point. Instead, it is flung outward, stretched by its own rotation, into a one-dimensional ring. This is the ring singularity. It changes everything. In the Schwarzschild model, the singularity is the center. To fall in is to hit the point. But in the Kerr model, the singularity is a loop floating in the void. The absolute center of the black hole, the bullseye of the target, is empty. It is like the eye of a hurricane. If you approach the ring from the equatorial direction, you will indeed be crushed. But if you fall in from the poles or follow specific trajectories through the geometry, it is theoretically possible to pass through the center of the ring without intersecting the singularity. For decades, this ring was seen as a mathematical curiosity, a loophole that allowed science fiction writers to dream of wormholes. But Roy Kerr's 2023 argument goes further. He suggests that the ring itself might not even be a place of infinite density. Mathematics has revealed a path through the abyss, but nature is rarely so kind as to leave the back door unlocked. There's a reason we haven't seen what lies inside a mechanism that keeps the interior hidden from our gaze. But what happens if we ignore the warning signs and look anyway? In December 2023, the physics world was jolted by a manuscript uploaded to the RCIV preprint server. The author was Roy Kerr, now 89 years old, returning to the field he helped define, with a singular purpose to challenge how we have been reading the map for 60 years. His argument attacks the very foundation of the Penrose singularity theorem. To understand his defense, we have to look at the specific mathematical tool Penrose used to argue that spacetime must terminate the affine parameter. When you measure the life of a human, you use seconds and years. This is proper time. But Penrose's theorem relies heavily on the paths of light rays, known as null geodesics. Here lies the problem. Light does not experience time. For a photon, proper time along its path is undefined. There is no ticking internal clock that shows duration. Its internal clock never ticks. So to track the progress of a light ray falling into a black hole, physicists use a mathematical substitute called the affine parameter. Think of it as a counter or a ticker tape that ticks up as the light travels. Penrose proved that inside a black hole under certain conditions, this counter must stop. The affine parameter is bounded. It reaches a maximum number and cannot go higher. Penrose interpreted this mathematical ceiling as a physical wall. He concluded that if the counter stops, the path must end. The light ray hits a singularity. Reality terminates. Roy Kerr argues that this is a logical leap, a confusion of the map for the territory. Imagine a submarine diving beyond the limits of its depth gauge. When the needle freezes, one observer declares the ocean has ended. Another looks through the viewport and sees water continuing downward. In his 2023 paper, Kerr insists that a bounded affine parameter does not prove that spacetime itself has a hole in it. It simply means our chosen coordinate system creates a finite measurement for an infinite path. The singularity that Penrose predicted is not a physical object waiting to crush us. It is a coordinate singularity, a mathematical artifact, a glitch in the software we use to model the universe, not a breakdown of the hardware of the universe itself. If Kerr is right, and the end of time is just a measurement error, then what exactly is at the center of a black hole? For decades, we visualized the singularity as a physical object, a point or ring of infinite density where mass is crushed into nothingness. We treated it like a tangible monster hiding in the dark. Kerr suggests we should view it instead as an optical caustic. Look at the bottom of a swimming pool on a sunny day. You see shimmering webs of bright light dancing on the tiles. These are caustics, places where the curvature of the water surface focuses many light rays into a small area. At those bright lines, the light intensity is extremely high, but it is not infinite. And more importantly, the water doesn't break. A swimmer can glide right through those bright lines without being destroyed. Kerr implies that the ring singularity inside a rotating black hole behaves similarly. It is a region where the gravitational lines of force are focused intensely by the geometry of spacetime. It is a place of extreme curvature. Yes. But it is not a solid wall. It is not a place where physics dies. If you were to approach this ring, you wouldn't crash into a physical barrier. You would be entering a region of intense gravitational focus. The structure we feared for 60 years may be a geometric illusion. This reclassification changes everything. In Penrose's framework, spacetime paths terminate. In Kerr's framework, they may extend. If the singularity is just a caustic, a focused mirage, then the path through the center remains open. The geodesic lines do not snap, they continue. This means that in principle, certain trajectories could pass through the region without terminating. But this freedom comes with a terrifying catch. If the singularity is merely a mirage and the end of time never happens, then the story doesn't end. And if the story doesn't end, the timeline continues into a region that our physics was never meant to describe. If space-time paths continue through the mirage, they enter a domain our current physics cannot predict. Enough theory. The arguments of Penrose and Kerr are drawn on chalkboards, but the truth can only be found in the descent. To reach a verdict, we must leave the safety of the observatory and follow the trajectory the equations describe. You are falling toward a supermassive Kerr black hole. As you approach, the first thing you notice is not the darkness, but the speed. Unlike the static holes of textbooks, this object is rotating at relativistic extremes. The abyssal current of spacetime grabs your ship long before you reach the edge. You are not just falling down, you are being swept sideways, dragged into a cosmic whirlpool that defies navigation. You cross the outer event horizon. In a Schwarzschild black hole, this would be the moment of silence, the point where the outside universe is cut off forever. But here, the spin creates a violent dynamism. Looking back, the starfield above you doesn't vanish. It shrinks into a concentrated circle of light, a porthole to the universe you left behind. According to the old law, your depth gauge, the affine parameter, should be ticking down to your execution. The gravitational pressure should be rising to crush the hull, but the hull holds. The centrifugal force of the spin is fighting back, pushing against the crushing gravity, creating a tunnel of stability. You are falling through the trap, not into it. You pass through a regime Penrose argued could not exist, but as your ship stabilizes in the deep interior, the sensors scream a new warning. The radar isn't picking up a singularity in the center. It is picking up a wall of energy closing in from all sides. You have survived the fall, but now you must survive the storm. Ahead of you lies the inner horizon, also known as the Cauchy horizon. This is the boundary between the predictable universe and the chaos within. And guarding this boundary is a phenomenon that might be deadlier than any singularity. Physicists call it mass inflation, but you can think of it as a time tsunami. As you hover at this threshold, time outside the black hole speeds up relative to you. In the fraction of a second it takes you to cross this line, billions of years pass in the universe above. All the light, all the radiation, and all the matter that will ever fall into the black hole throughout the history of the cosmos is raining down behind you. Because of the extreme gravity, the rain of light is blue-shifted, its frequency boosted to unimaginable energy levels. It creates a thin, blinding sheet of hard radiation at the inner horizon. This is the blue sheet. It is the sonic boom of eternity. For decades, physicists believed this firestorm wall was impenetrable, that the energy density here would become infinite, vaporizing any ship that tried to cross, effectively resealing Penrose's prison. But modern simulations suggest a loophole. If the black hole is rotating, the energy might focus and disperse just enough to create a weak singularity. It will not be a smooth ride. As you hit the blue sheet, the ship is hammered by the condensed history of the universe. The structure groans under the tidal shock. The radiation shields flare white hot. But unlike the crushing grip of the center, this barrier is thin. The crossing happens in a violent, uncontrolled burst of energy. The hull vibrates violently. The alarms deafen you. And then, silence. You break through. You are alive. You have done the impossible. You have crossed the bridge. You are now floating in the deep interior, the region Penrose said could not exist. Below you, the ring singularity glows not as a monster, but as a magnificent, shimmering, optical caustic, a halo, of focused gravity floating in the void. Certain trajectories pass through the center of the ring without intersecting the caustic. But as you look at your navigation computer, the relief turns to a new kind of horror. The screen is glitching, not because of damage, but because the software cannot compute a path. In the universe you came from, physics is deterministic. If you know the position and speed of a ball, you can predict exactly where it will land. Cause leads to effect, past leads to future. Here inside the inner horizon, that chain is broken. You have entered a region of a causality. The spacetime here is so twisted that time loops back on itself. The future is not determined by the past. The equations of general relativity lose their predictive power. There is no script here. Events here are no longer uniquely determined by initial conditions. You could meet a version of yourself that hasn't arrived yet. The universe has stopped functioning as a logical machine and has become a generator of random events. This is the price of survival. Penrose's singularity would have killed you, but it would have done so following a strict law. Kerr's solution lets you live, but it strands you in a place where laws no longer apply. You have escaped a deterministic ending only to find yourself in a reality where the concept of destiny does not exist. So here we stand at the edge of the evidence. For 60 years, the singularity was the ultimate verdict of physics, a final, inescapable execution. But Roy Kerr has reopened the appeal. His calculations have shown us that the structure at the center may be a coordinate effect, a geometric mirage created by our choice of description. Under a different perspective, paths that once terminated may instead continue. But this liberation comes with a heavy price. We are left with a choice between two terrifying realities. On one side, we have the Penrose universe, a place of strict order where cause always leads to effect, but where every story must ultimately end in total annihilation. It is a universe that remains intelligible right up until it terminates you. On the other side, we have the Kerr universe, a place where you can survive the fall, where the tunnel remains open, but where the logic of history dissolves into the chaos of the acausal zone. It is a universe where you live, but destiny dies. Perhaps this is why the universe seems to enforce the cosmic censorship hypothesis. Perhaps nature creates event horizons not to hide the singularity from us, but to hide us from the madness inside. The event horizon is a quarantine wall. It protects the sane, predictable physics of the outside world from the acausal insanity of the interior. Roy Kerr has given us the math to break through that quarantine. He has argued that the end of time may be a myth. But in doing so, he has forced us to ask a question that physics is not yet ready to answer. If the bottom of a black hole isn't a trash compactor that deletes reality, then where does the tunnel go? And if we ever find the courage to dive through the mirage and enter that chaotic ocean, will we still be human when we emerge on the other side? The case of the singularity is reopened. The verdict is suspended. For the first time, the verdict remains unresolved.